Okay, this video we get one now.
What's the date?
All right, so we've done a few problems already that have to do with compounding interest. So now we're going to take a look at what it means to compound interest in something that's other than compounding annually. Let's take a look at this video. Okay, in this video we're going to look at compounding interest. So let's take a look at example number 1 from your notes. If $400 is invested at 5% per year, compounded annually, what's the total amount after 6 years? Okay, so we recognize this as an exponential growth type problem, which means we're going to be using y equals a times b to the power of t, our standard form of our exponential function. And we just need to know what are going to be our values of a and b. A is our initial value, b is going to be our growth factor. And once we have those two values, well, we can just plug in t equals 6 here, and we can calculate the amount of money we're going to have in our account after 6 years. Okay, so let's do that. So a, and remember a, that's my initial value. So a is just given to me in the problem, that's $400. Okay, my initial value is a. Now b, in order to calculate b, that's my growth factor. And I remember in order to calculate my growth factor, I need to know my growth rate. So r, that's my growth rate. And r is also given to me in the problem, it's 5%. Although, I remember I have to express that percentage as a decimal. So, 0.05. Okay, now I've got r, my growth rate. And now I'm ready to calculate b, which is my growth factor. And my growth factor, I can calculate using this little equation here, 1 plus my growth rate. Well, I already know my growth rate, it's 0.05. So 1 plus 0.05. And now I have b, my growth factor. So now I have everything I need. I just plug in a and b here into my function. A is 400. B is 1.05. 1.05 to the power of t. Now, if I want to know the total amount that's going to be in the total amount of my investment after 6 years, well, I'm just going to calculate the value of y after 6 years, 1.05 to the power of 6. And if I put that into my calculator, I get $536.04. All right? Okay, so far so good. Now, the next example, we're going to look... Everybody good so far? Yes. Just calculating the growth factor based on the growth rate, plug it in. What's that?
Wait, never mind.
You good?
Because I was confused by the compounder, like the definition of that. But
compound annually, yeah, we're going to talk about that in the next slide in just a minute. Yeah, so far, however, this is just like the other, interest problems that we've looked at. All right. All right, let's take a look at this next. Look at what would be the amount in our bank account if we didn't calculate our interest once a year, or if we calculated it more often than once a year, and that's called compounding interest. So let's take a look at that example. So example number 2, the same $400 is invested at 5% per year. Again, that's the same interest rate that we had before, except this time it's going to be compounded semi-annually. In other words, instead of calculating interest and then adding that to the account once a year, we're going to be doing it twice a year. All right, so once in the middle of the year, once at the end of the year. So now, again, we want to know the total amount after 6 years. Okay, well, again, I recognize this is going to be an exponential growth problem, which means I'm going to be using my exponential, the standard form of an exponential function. This time, however, I'm going to write it like this. Instead of writing it a times b to the power of t, I'm going to write it as a times b to the power of x. And you're going to see why in just a minute. Okay, so now, once again, I need to figure out my values of A and B, my initial value and my growth factor. All right, well, my initial value, A, again, that's the same thing it was before, $400. All right, to calculate my growth factor, again, I have to have my growth rate. And now here's where it starts to get a little different from the example that we had before. The growth rate is given to me in the problem, but notice my growth rate is given to me as a yearly rate, an annual rate, 5% growth per year. And yet I want to compound my interest, that is, I want to calculate my interest payments every half year. All right, so I don't want to use an annual interest rate if I'm compounding semi-annually. I need a semi-annual interest rate. Well, the way I do that is, instead of getting 5% per year, since I'm going to be calculating interest every half year, well then I just take my yearly interest rate and I divide it by 2. So my growth rate is going to be 5% divided by 2. That is my annual growth rate divided by 2, which gives me 2.5%, or, remember I have to write that as a decimal, 0.025. All right. Now again, remember this value right here, this is my growth rate, but more specifically, this is my semi-annual growth rate. All right. My annual growth rate was 0.05. My semi-annual growth rate is 0.025, half of my annual growth rate. Okay, so now I got R, my growth rate. Again, I want to calculate my growth factor, and my growth factor is 1 plus my growth rate. I have my growth rate here expressed as a decimal, 1 plus 0.025, which is 1.025. Great. Now I've got A, I've got B, so let's put those in. Y equals 400 times B is 1.025 to the power of X. Okay, now we need to talk about what is this value here going to be. So in the previous example, the value here was just 6 because we were talking about A times B to the power of T. And T, we've been talking about how, well, that's time, and we've leaving our money in our account for 6 years. So you would think, well, that's how long we are going to be leaving our money in here, so wouldn't that number be 6? Except that number here is really not, it's not time, it really is how many times are we going to be calculating interest on our money. And in our first example, we calculated interest on our money 6 times at the end of every year. Well, now we're not going to be calculating interest 6 times, we're actually going to be calculating it 12 times because we are compounding interest semi-annually. That means we are going to calculate interest in the middle of the year and at the end of the year. Well, since we're doing that for 6 years, that's twice a year for 6 years, the value here is 12, or 2 times 6. All right, so this number here, it kind of has gone from being a time value to being the number of compounding periods, or the number of times we're going to calculate interest. So this value now is 12. Now I'm ready to calculate my interest. 400 times 1.025 to the power of 12, and I punch this into my calculator, and I find that the total amount in my account after 6 years is going to be $537.96, or a little bit more than I would have gotten if I had used annual compounding.
This looks different from where we did semi-annually. I remember the teacher dividing the percentage by 2. I remember her putting it regularly, and then she just like doubled the amount of time since it's semi-annually.
There are different ways to approach these types of problems, and it sounds like you're talking about a slightly different way of doing this. So yeah, there are different methods. This is one way, and at least for now, this is kind of where we're going to start. We're going to look at some of those other ones. Any questions on that? All right, so you'll notice on the back of this set of notes, you've got another example where it asks you to calculate how much money you're going to have in an account with so much money to start with. If you compound annually, semi-annually, monthly, and daily. All right? And now you're going to be getting 4 different amounts of money in your account depending on how often you compound. All right, so if you haven't already, go ahead and try this example, and let's see if you get the same answer that I did. Semi-annually means you're going to be calculating twice a month. Monthly means you're going to be calculating about 12.
Can I hold that calculator when you're done?
Yeah. Yes.
Okay.
Mr. Blesson. All right, calculators in here. Me. Are there any calculators in there?
There's one, see that gray one around there?
I do.
What's the 90 goes right here? Growth rate? What is it?
I get. This one, I don't mind it.
That's your problem
Important.
solving. Yes. You mean your final answer? Oh, let's say on your for your growth factor, let's say we'll go to 3 decimal points. Correct. To get your new growth rate? Correct. Correct. Yes, G.
Okay, so for it's compounded
You want to pass that back when you're done?
0.5 divided by 365, right? How would you put that Yeah, I know. I think we're so 9.5
You got it already?
Which round?
Go about these.
What's that?
Go about these.
Yes, but yeah.
Okay, so I tried it before at first, but it gave me the wings from the that would be, that you're saying that that's more than that. I think you did this before.
Don't mind if I do this?
No.
Yeah.
Okay, so I think it works here. So what you do is, that is
That's what
no, or no one. Like,
No, it doesn't.
Do we multiply the 0.035 by the 2?
You take your original position.
oh, so like, that means it's not there.
Correct.
Okay.
which is 1.75%, and there's 12 months.
No.
Did you attach those things to your
I divided the decimal instead of the percent.
I just looked at that. We just divided. I believe it has a decimal. And this, what, it had I, but it fell off. And I believe this. And this right here. I tried to write it in 2000.
Yeah. But I said I'm redoing it.
Did you put 0.00291?
And then that last year, I just put 0.002.
So is that this one?
So I'm not sure.
You do 3.5 divided by 4. What, 0.3?
Yeah.
Why do you divide by 4? You divide by well, you get the same answer.
Semi-annually means every half year. Just like
Anyway,
invisible.
so, no, but you.
So it'll be twice a year.
They did 5 divided by 2. Yes, so we do 3.5 divided by 2. No, you do 3.5 divided by 12. Or divided by 12.
Yes, it's rolling.
It's not the root 2 places.
It is rolling.
What? No, you only move it once.
Camera's rolling.
Do you move the decimal 2 places or no 1 place?
2.
You divide 3.5.
What?
You have to change your.
And then to the 8
Because you have to times it by however many times.
I haven't done it, but I can figure it out. Give me cough pack. Give me cough pack.
You have to divide 3.5.
How did you get the same message to Eggman?
Then do you still move the decimal place over twice?
Yeah. Okay, so 3.5 divided by 2. Then you get
See, the way it's angled, you can't see that. If you do, just everybody will see.
So it's 1.015.
I'm gonna do that.
so it'd be 1.5. I think you should do that.
We're going to talk about.
I'll edit that.
There.
How
Did it.
many numbers do we need here for now?
Ooh, an egg.
Yeah, no, I copied off the board.
What? I'm not good for still be Ice. Look what it said. Ice. Ice. It said ice. Excuse me. Look.
I don't know.
Oh my gosh. But it's so small though. You can barely tell.
But you can tell that it's. Hey,
You're not gonna finish it. But I'll tell you what happened. And then after you watch it,
No, it can't see you.
you can't see me. You see everything that just is.
It can see your arm though.
is he recording?
Yeah.
Oh.
Why?
Is he recording?
It's only 21 minutes. Yes. It's been recording for the last 20 minutes.
He has. Oh, sorry.
Wait, is it keep recording multiple
You
videos?
know that he can hear you on the recording. You have to have a zero right here.
He probably.
That's all two places, not
Camera had a beautiful view of your jacket.
Watch this. Twisted.
Stop. Don't do that. You're stupid. Did it just turn off? No.
Here we go.
What's wrong with you? Did she?
Oh my god. Oh my god.
What if you just
It's a big crack part. I would do that. Am I online? I would go to the camera and be like, am I online?
Oh, I didn't understand it at first.
Alright, let's take a look at these.
You're gonna miss out so much. It's gonna be so sad.
I'll fill you
Which, let me get everybody's eyes on me, please. So, hopefully everybody got 3A without too much trouble. If I get 3B?
Yeah.
If I get on 3B? Yes. Alright. Where I usually start getting questions, and I did today as well, is on 3C, and usually the questions start right about the place where you go to calculate your monthly interest rate. All right, now 3.5% is my annual interest rate. Christian?
When it says 1.002917, I just put 29. I ended there. I didn't put 17.
Yeah, in fact, that's what it's going to do as well. Yeah. So, notice if I take my annual interest rate, 3.5%, and divide it by 12 to get my monthly interest rate, I get 0.2917%. Not 0.2917, 0.2917%. Alright? And that's important. When you get this number right here, you have not yet converted your interest rate from a percentage into a decimal. Alright? In order to convert this percentage into a decimal, Connor, what do I have to do? Yeah, I got to move my decimal point 2 places to the left. And when I do that, now I've got my monthly interest rate expressed as a decimal, and this is what I add to 1 in order to get my growth factor, which is what we did right here. All right. Now, some of you, you round it differently. Some of you, you said 1.0029 instead of I said 0.002917. Now you're just talking about rounding. All right. We're going to talk a little bit more about that as we go. But if you round it this way, we did, that's fine. All right. Connor.
I got 1,297.
Are we talking about C?
Yeah, I did 1,000 times 1.00292.
Yeah. Yeah, and what Connor is pointing out, and I suspect this happened for a lot of you, depending on what number you put here, if you use 1.00292, you're going to get a slightly different answer than if you use 1.0029 or if you use 1.002917. That's rounding. Right? Depending on how you round this number right here, you're going to get a slightly different answer. And again, we're going to talk about that in a little more detail later on.
Would you count that wrong for D?
I would not.
So,
I would not. On the test, when you do problems like this, I'm going to say specifically, give me this many decimal places for your growth rate. All right? If I don't tell you specifically, you can pick a number and then, you know, whatever you happen around to. So
I don't think why they took out 2.
they took out 1, 2, where?
1.0292.
Well, if I were to round this to 5 decimal places, I would get 1.00292. Soon, when he rounded to 4 decimal places, and so he got 1.0029. He just rounded it. All right. Everybody good on D? I'm doing the same thing I did on all the other ones. It's just now I've got 365 compounding periods. I got to divide my interest rate by 365. Yes, it is. Yeah, at this point, I know a lot of y'all are, you know, kind of upset because, well, what if I get exactly the number that, you know, Lucien wrote down? I'm not that concerned about that right now. That's just rounding error. Presumably, if you got a number different from this one, then the number that you have right here is not exactly 1.0000958. It's maybe 1.00096. That's or you got a slightly different number. If you got a slightly different number, then your answer here is going to be slightly different. I'm not concerned about that rounding right now.
With the test, do you want, like, what's the rule that you want us to use to round?
Again, I'm not concerned about that right now, but we're going to talk about that in more detail later. If you're in the ballpark here, you got roughly this answer, then you're good. All right. And now notice, what do you notice about, we calculated, you know, this amount of money compounding annually, what is this, annually, semi-annually, monthly, and daily. What do you notice about the amount in your bank account after 7 years?
It is increasing.
It's increasing based on what, Jordan?
Yeah, the income.
Based on what?
How often?
No, how often? Yeah. How often you like do the interest and the compounding?
Exactly. Notice the only thing that's different about these 4 ways of calculating that we did here, the only thing that's different is how many times are we compounding? How many times are we calculating? Are we doing it once a year? Are we doing it twice a year? Are we doing it 12 times a year? Are we doing it 365 times a year? The more often you compound interest, the more money you get in your account. All right? It's still 7 years, but this is compounded annually, this is semi-annually, this is monthly, and this is daily. And I make more money the more often the bank compounds interest.
Yeah, but it's like $5 difference over 7 years. Like, you don't even notice that.
Well, it's a $5 difference over 7 years if you've only got $1,000 in your account. That's true.
Yeah.
And I know for some of you, $1,000 may sound like a lot of money, and you don't have $1,000 in your bank account. But if you've got, you know, $10,000 in your bank account, or maybe $50,000 in a retirement account, or maybe a couple of $100,000, now all of a sudden, yeah, this is going to start to make a big difference. Yeah, and that's exactly, you know, that's exactly where this, you know.
What is something like the compounding of gold? Like, if you had it in bank, like, how do you, what's the difference between, like, just checking it annually and checking it, like, daily? Like, would you actually have to, like, check something? Like, what?
It's not so much about, like, if you are the person who has, you know, a bank account with some money in it, it's not so much that you are going, you know, to check to see how much money is in your bank. It's how often is the bank going to add interest into your savings account? How often are they going to do the calculation to decide, you know, how much interest do we need to do? Are they going to do it at the end of every year? In which case your $1,000 just kind of sits there for, you know, all the year until, you know, December 31st. Are they going to do it twice a year? And they're going to add that interest in, you know, in July and then in December? Are they going to do it at the end of every month? Or are they going to do it every night? That's the bank calculating how much interest to add into your account. That's what the compound is. Massive.
I know this is kind of like this big choice, but is it your choice or the bank's choice?
Good question. In general, the banks decide how often they're going to compound. Also, and we're not going to talk about this in this class, although again, next year you probably will some more. There's the notion of, you know, you can kind of see, oh, well, look, you know, we're compounding, every time we compound more frequently, I get more money in my account, which is a good thing for me. This is compounding daily. Shoot, can I maybe compound like hourly? Could I compound every minute?
That'd be.
Yeah. In fact, yeah, what that kind of moves toward is this notion of compounding continuously. And that may sound kind of freaky to you, but in fact, that's what most banks and financial institutions, they're doing what's called compounding continuously. And mathematically, that has some really interesting kind of effects, and it involves this thing called the number E, which you may or may not have heard of. Yeah.
Isn't that like what shows up on calculator sometimes?
It is. It's called the base of the natural logarithm system, and we're actually going to talk about logarithms a little bit more before too long. This is kind of like, this is the hard thing. When you start compounding more and more frequently, and eventually you're just compounding continuously, like you're compounding an infinite number of times over 7 years, you get to this thing called the natural logarithm, or the base of the natural logarithm, and yeah, it's just kind of an interesting mathematical thing that happens, and this is basically what banks do all the time. It's like an ordinary thing that they do. The math becomes a little bit more complicated than this, but it's basically the same. All right, we got a question.
I don't really understand banks, but like, so if I give them $1,000,
yeah,
and come back 7 years later, it'll be like 1,000, like 1,200 or something.
Right.
Why?
How does that happen?
Like, why are they giving me money?
It's a good question with a much longer answer than I can give, but banks are essentially taking, if not all of your money, they're taking some piece of your money and they're investing it.
Yeah.
So they're taking your money, they're kind of investing it for you, and those investments are, you know, kind of bringing in more money, and that's where that interest comes from. That's kind of the short.
What if they lose money though? What if they make a bad investment?
Then then they gotta basically eat the losses, because you're gonna be getting your money back. And actually, I guess an even better answer than that is if a bank does like make a colossal screw up, like you may have heard in 2008, there's this thing called the Financial Meltdown, or this big, the Great Recession. It was like this worldwide kind of banking collapse. It was pretty bad news. Most bank accounts in this, actually all of them in this country, they're insured by the federal government. It's called Fdic Insurance. Basically, the federal government says, as long as you don't have more than $100,000 in a bank account, we got you covered. If your bank messes up and goes belly up and loses all its money, we're going to give you back your $100,000. The U.S. government's got you covered. Now, other countries, maybe not. But in the United States, at least, there's this it's called deposit insurance, and you got that on all your money. So the federal government's got that.
Why does it stop at $100,000?
Say again?
Why does it stop at $100,000?
Good question. It's basically, a way for the U.S. government to say, look, we got you covered up to this point, but if you got like $50 billion, but you're a really rich guy, and you make a bad investment, and your bank goes, sorry. Okay, I know y'all are going to be upset to find out that I'm not giving you homework over the break. Sorry.
What's wrong with you?
I know, I'm sure you'll find something to do with your time. I have a few students who asked about review problems that they might want to work on prior to or during the break. I don't have hard copies of that to pass out to you. However, there are some on the website. If you want to go ahead and take
Let's do that. Why'd you do that?
after the break.
Let's do it again.
Okay?
I don't have to unwrap it. I don't want to unwrap it.
I broke my palate.
Time serves a man like to put this back with this last blitz. So it did. It's still recording. I got something for that camera.
Don't do that.
For the video,
Yeah.
I wanted to have an explanation because I tried uploading it yesterday, but my computer stopped working.
Yeah, when you send me the link, just make me a little note in the email. I tried to send it earlier.
Wait, it's due at 12 o'clock tonight, right?
Correct.
Yeah, okay.
I tried to upload it on my iPad, so I ended up uploading it tonight, and it's still like 15
Why don't you go to baseball with us?
Because my mom was like, you have a date.
See, that's why I have Android.
You're not doing anything.
It's not even free.
honest, I kind of like baseball. What's wrong with it? Exactly. What's wrong with it? I play baseball.
Like honestly,
I mean, the sports people think is boring. My dad thinks football. Hey, you got your first sports. We have my dad hates football. American football or soccer? American football. I'm pretty sure soccer is better.
Yeah, I'm playing baseball. I've played baseball one season. I got like 3 balls.
You look so good. You like. Because he was, when I wake up, everyone's I can't even walk right. But I got the bed when I walk outside. I like running to the walls. And my mom will wake up. I woke up at like 5
I found my alarm was I was like, hit my desk. I was like, I hit my pillow. I was like, where's my
Exercise wise, probably.